So that is our ultimate aim of our journey. As you know, right now today we have in a crisis situation, economically, socially, and so on. World has recognized for the time being Sri Lanka is a failed state, and there are so many things that we have seen. Something like people are in the queue to get the fuel and the gas and so forth. What we understand is that right now we have a crisis on foreign currency. That simply say that we are bringing the more goods to Sri Lanka than what we are sending. Other way that we have a problem in earnings of foreign currency. When you look carefully, that we understand that we spend money on the energy and essential goods and so forth. Then what is the way forward? Way forward is sustainability play a key role in there, because whatever we have to make sure that the energy efficient, material efficient, water efficient, and so forth. So this is where the Green Building Council of Sri Lanka play a major role for the national economy of the country. So when you look at the big picture, that we must go for while producing the renewable energy and the material and so forth, we have to go for the efficiency and sustainability. So this is the topic that we are talking about. The institution carbon footprint calculation is a part of it. So we have gathered the expert of this country, and they will conduct the courses within today. As you know that we not only conduct this kind of courses, we have a variety of courses. You can talk to the officers of the Green Building Council and learn how it is done, and you are welcome to be part of the Green Building Council and go toward this development of sustainable nation. With that, I would like to congratulate for your decision to be a part of this important workshop. I wish you will have a wonderful day. Thank you.
Thank you very much for introduction and for the warm welcome. Coming to the end of the inauguration ceremony, again I would like to thank Professor Ranjit Disanayake, Chairman of the Green Building Council of Sri Lanka, and Mr. Layan Nawagama, Director of the Green Building Council of Sri Lanka, for their constant guidance and encouragement, which certainly takes the Green Building Council of Sri Lanka to new heights. We would also like to appreciate your active involvement to bettering the industry and for your professional involvement with Green Building Council, society and country as a whole. With that, I conclude the opening ceremony of the workshop on institutional carbon footprint calculation. Let's move on to the first educational session of the day. The session will discuss on Introduction to Carbon Footprint Calculation and the Importance. The session is conducted by Professor Karnellඳ. Sir, it's my honor to introduce you to the gathering. Professor attached to the Department of Chemical and Process Engineering, Faculty of Engineering, University of Peradeniya, Sri Lanka. He also serves as the Deputy Director of the Center of Environmental Studies, University of Peradeniya. As well as he graduated from the Faculty of Engineering, University of Peradeniya and obtained his PhD from the University of Nova Lisbon, Portugal. He is the founding president of the Life Cycle Assessment and Design for Sustainability Network Sri Lanka and a member of the Board of Directors Sri Lanka Sustainable Consumption and Production Forum. He held the membership of American Chemical Society and Sri Lanka Energy Managers Association. Professor Karunarajna is actively involved in the promotion of concepts such as cleaner production, life cycle assessment and environmental management. Yes sir, I cordially invite you to conduct the lecture session.
So good morning everyone. Okay, I will take maybe, you can switch over, please. I'll take maybe something like now 45 minutes to introduce why actually we should be worried about carbon footprint, our personal, organizational, or as a country. And then also the use of this carbon footprint calculation. Why as an organization we should calculate the carbon footprint and move beyond the calculation. Calculation will only give you how much GHG emission is you are responsible for emission, but not only the calculation, but after that actually that information you have to use. Okay, I'll use this. Okay, so and also we will look at actually how the workshop has been arranged and why actually this presentation we have arranged. So because there is a flow and also a rationale behind the entire program, and we will discuss that also. Now, first of all, I think okay. So most of you already may be aware of the carbon footprint. What is it? And also some of you are probably not very much aware of it. Then also the purpose of doing this workshop, I mean as a participant, what is your objective, that is also important. Because this probably will give you certain opportunities as a person to do some consultancies and then also maybe in the organization improvement. But actually the true intention should be actually improving the sustainability of the organization, of the country and the world as a whole. Now, I don't know whether you have seen this picture actually. I don't know whether it is very clear also. Now, have you seen anyone? Are you familiar with this picture? It's a very famous picture in environmental arena. Anyone? Yes? Okay. Now this is a dot actually. There is a dot here. And this dot is very important. Now what do you think that is? Can you guess it? Shouldn't be difficult. Where all these things happen? Do you know any other place other than this Earth? No. This was actually a picture taken by Voyager when it leaves the solar system. So something like 6 billion kilometers away from the Earth. This one is actually 3D, so you have millions or billions of pixels. But actually on this picture, on this 3D picture, only this single dot matters. Okay. Without this, we are not going to be here. And without this, our future generations will not be here. Okay. We don't have any other place to go. All the resources come from this one, and all the waste that we generate should be processed by this one and provide necessary space for us, and especially other maybe millions of species. Okay, so this is the only dot we have. So all our intention should be towards this, protecting this single dot, the Earth that we have. So as we saw also during the videos, we are facing certain problems, especially related to sustainability. And actually, if you don't tackle these problems properly, in maybe 200-300 years time, even the existence of humankind will be a questionable thing, because some of the problems are so severe. Okay. Now, if you look at some of the global environmental issues we are facing, the biggest one is global warming that we are going to discuss, and today's focus is that one. But in addition to that, we have many other things like acidification or acid rain. That is basically because of emissions of nitrogen and sulfur oxide from combustion of mainly sulfur-containing fuels, and that will generate sulfur dioxide. But also nitrogen plus, anyway we use nitrogen in air during the combustion. So if the combustion temperature is high, again that nitrogen will be converted into nitrogen oxide, and then ultimately they will result in this decrease in pH value in rainwater. And that is one part of the acidification, but also because of the increased level of carbon dioxide in the atmosphere, where the pH of seawater is also dropping, because seawater is in equilibrium with carbon dioxide in the environment. Okay, so as a result, that will also become, it's not going to be like pH below 7, but it's already basic. But even a small drop of pH value can have impact, especially on these marine life with shells, because these shells will dissolve if the pH level decreases, and then seawater become bit acidic. Then also we have eutrophication, which is actually a result of discharge of this nutrient to water bodies. So as a result, you will have algae blooms, and then the dissolved oxygen will be consumed, and then ultimately there will not be any remaining dissolved oxygen in water, so that the life can thrive there. Okay. Then also another problem, which probably we have tackled to a certain extent, is the ozone layer depletion. What is actually ozone layer depletion? You can't be like this, you are going to sleep in no time. So what is ozone layer depletion? No different from our student. What is ozone layer? Where is it? Stratosphere. Where is this stratosphere? Up there, maybe something like about 11 kilometers up. So what is the use of ozone there? Because we don't go there, we only live here. All the life is below that. So why should we worry about something up there? Yeah?
It's protecting the earth from the ultraviolet rays.
Of course, because this ozone absorbs this high energy UV radiation, the short wave UV radiation, and then it prevents those ozone there prevents this ozone coming into the UV radiation coming into the Earth's surface. So without those ozone, actually, again, we will be threatened because this UV radiation is high energy, and then that can damage our DNA and so on, and then you can have skin cancer and so on. So what happened to this ozone? Why it is depleted? What is happening? CFC, chlorofluorocarbon. So these are actually some of the man-made material, chlorofluorocarbon for refrigerant initially, because earlier refrigerants were like ammonia, they were harmful, you had fire hazard, toxic, and as a replacement actually these chlorofluorocarbons were introduced. Actually they were best, because they didn't have any fire hazard, they didn't have any environmental hazard, and they didn't have health hazard. So they were considered to be very good because these are very inert material. But since these are inert, they stay in the environment for a long time and then gradually move up. Okay, so gradually this will reach the stratosphere, and there things are different. What is the main difference? Something we don't have here is there. That is that high energy UV radiation. Okay? So that high energy UV radiation is capable of removing chlorine radicals from the CFC molecules. Then these chlorine atoms actually participate in a reaction that converts ozone into oxygen. And chlorine is only a catalyst. So as a result, catalyst will not participate in the reaction. At the end of the reaction, it will be available for another reaction. So that means one radical of chlorine can destroy or convert ozone into oxygen. Maybe thousands of ozone can be converted into oxygen by one chlorine radical. So that is how the destruction happens. But fortunately, that was identified thanks to a brilliant of few scientists, and now actually the world has taken a step to address this. So this is something probably you can be happy of, because this has been addressed to a certain level. Okay. Then another bigger threat is the resource overconsumption, depletion of resources. Even renewable resources, if you consume at a faster rate, then it can be generated, then you are going to actually gradually deplete these resources. So this is what is happening. Now at the moment, to sustain our lifestyle, we need resources from something like 1.5 Earth. We have only with that dot. Okay, now we are consuming resources from 1.5 Earth. That means to maintain sustainable lifestyle, if we had another Earth, then we can live like this. But we don't have. So what we do is, actually we are consuming our deposit, like fixed deposits, and then gradually our fixed deposit will be over. And we will not have resources for future generations. Okay? So this is one of the biggest problems we are facing. But among them, the biggest threat actually we are facing is the first one: global warming and the associated climate change. Okay. So our focus today is this one. So what is global warming? Can someone take the time and explain what is global warming? What happens due to global warming? Earth's temperature gradually increases. So that is why it's called global warming. That's the warming. But how it happens? CFC gases, part of it. But CFC is mainly responsible for that ozone depletion. Greenhouse gases. So how they contribute to this warming? They are going to reflect.
IR waves to the earth.
Okay, so where do you get IR radiation?
From the sun.
From the sun? Or somewhere else?
Reflected waves will remain.
Okay, so somehow these gases will trap. It's correct, it's IR radiation. Okay, the thing is this. Now if you take, okay, so if you take the earth, we receive energy from the sun, and then part of it will be reflected, part of it will be absorbed by the earth. Okay? And then also, because when you have a temperature of an object to above, let's say, above absolute zero, then you will have emission from that object. Any object will have that temperature. Okay? Now, if you look at actually the wavelengths of this emission, these are basically inversely proportional to T to the power 4. That means higher the temperature, shorter the wavelength. Now, if you take sun, which has an average temperature, so the average we calculate as 6000 Kelvin. So as a result, it has a very low wavelength spectrum. Now, this is the distribution of wavelength of the solar radiation. Okay, short wave. So this is the wavelength. Okay, so less than, let's say, 2 micrometers. Okay, majority is somewhere here, about 0.4. This is the same spectrum for Earth's temperature. Okay, so now you see these are actually longer wavelength than this. That is one part. Second part, if you take a molecule and if you direct energy of different wavelength at particular wavelength, these molecules will absorb the energy. Only in that particular wavelength. So we call it, most of you probably know, as the absorption spectrum. So now, for example, if you take water vapor, in this region, actually this wavelength range, all the energy that you direct will be absorbed by this molecule, but not in this range, but again here. Okay. So same way if you take carbon dioxide, here you don't have like absorption, but here you will have absorption. So if you put these peaks in this one, these are those peaks. Now you see these gases like carbon dioxide, then methane, mainly those are nitrous oxide, they don't have peaks in this region. It's like here. So that means this solar radiation will not be absorbed by this gas. So solar radiation will come and part of it will be reflected. But you see, corresponding to Earth radiation spectrum, there are a lot of peaks. So that means actually this wavelength radiation is absorbed by these gases. So these are actually what you mention as IR radiation. So this Earth emission is in the IR range and those are absorbed by these greenhouse gases. So after absorbing, they will be re-emitted and basically the energy will be retained. So part of the energy that should have left the Earth's atmosphere is retained by these gases. So it upsets the energy balance. Okay, so this is what basically happens in the global warming. So there are 6 main greenhouse gases we use even in calculation. So these are the listed under the Kyoto Protocol, mainly carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, chlorofluorocarbons, and sulfur hexafluoride. Okay, so they have different impact, as you know. Now we take carbon dioxide has like 1 impact. Compared to that, we compare the global warming, we call it potential of other gases. Like if you take methane, it has a potential something like 25 times carbon dioxide. So that means emission of 1 ton of methane is equal to emission of 25 tons of carbon dioxide. So that means that is how you get that carbon dioxide equal. 1 ton of methane is equal to 25 tons of carbon dioxide equal. Okay. Impact in terms of global warming. Now, What do you think? Global warming is bad? Bad. But actually, without global warming, we are not going to be here. Yeah. Because or thanks to these greenhouse gases, we have a temperature around 15 degrees centigrade. The average global temperature is 15 degrees thanks to these greenhouse gases because they absorb energy. So without these greenhouse gases, the temperature would have been something like minus 15 average. So that means no liquid water, no life. Okay. Then what is the problem? Why we are worried about it? It's too much. Okay? Too much of anything is not good. So this is the reason. So you see actually, historically, these are very stable concentrations. And this is where the balance. Now what we have done is, we have upset this balance by increasing these gases exponentially after 1800. So what happened in this 1800? Industrial Revolution. So what does it mean? Mainly use of lot of fossil fuel. If you take mainly during that period, it was coal. Now coal has carbon which is meant to be inside the earth, not in the atmosphere. So what we have done is, we have taken that carbon out from the earth plus burn it and sent that gas into the environment, which was never meant to be in the environment naturally. Okay. So this has upset the carbon dioxide level, and as you can see, not only carbon dioxide, all other gases are, because you have like one source of these gases, also like even some amount of methane will come from combustion, but also other industrial activities will generate these gases. So this is the problem, too much of it. Okay, so now if you look at the recent trend from let's say 1955 up to now, so starting from 310 ppm. So still it is small quantity, ppm. What is ppm? Parts per million. So if you take 1 million parts, 1 is 1 ppm. Okay. So now, starting from let's say 315 or so, now actually it has gone to something like 420. Okay. So within these few decades. So this is a very high increase actually. Okay. So this will result in the increased concentration. So what is the value now? Any idea? CO2 level? So this is the value in on the fifth, something like 414.8 compared to 213.4 a year ago. Okay. So this gradual increase actually is because of that greenhouse effect. I mean, this will result in the greenhouse effect increase. So it's like this now. For example, it's a balance, as I told you, energy balance. If you take a tank, now let's say you have a tank, and if you have an inlet and outlet, and if you open water, and then gradually the water level increase, and then because of the pressure, this level will gradually, this flow rate will also gradually increase, starting from a very low value. So at a particular level, these two will be equal, and then you will have a constant level. That is the steady state. Okay. But now what you do is, you gradually restrict the outflow, reduce the outflow. Okay. Then what happens? This gradual level will gradually increase. So this same thing happening to the energy level on the earth. We are restricting gradually part of the energy that should have left the earth by increasing the greenhouse gases amount. Okay. Okay. So now it is 420, let's say. Is it a big issue? How much of the impact of this one? Okay, now we know it is going to increase the temperature, so let's see how it has increased the temperature over the time. You can see the time is the average between this. Okay, so this green mean average, it's a negative value, but this red means it's a positive 2 degrees increase. So it's still going up and down, but not now. Okay, so you can see now, earlier it was fluctuating between blue and red, but gradually after especially 1980s, this became gradually red, and part of somewhere here, the North Pole is almost like 2 degrees increase already. So 2 degrees maybe it's nothing, as probably we think, but actually it has already a lot of problems created that small rise in temperature. Okay. So this is what has happened, and also there are projections depending on how we, let's say, develop economy and so on under different scenarios. We have projections. So some projections actually say, like maybe business as usual. If you don't do anything, at the end of this century, we will have a 4 degrees rise of temperature compared to, let's say, in this case, I think it is compared to 1980. 4 degrees. Should we worry about it? Now, have you heard about Paris Agreement? So, what is the target of the Paris Agreement? To limit the temperature rise by maximum 2 degrees, but preferably 1.5 compared to what? Compared to pre-industrial era, before all that happened. Okay. Now we are going to limit it to 2 degrees, but in this case, if you don't do anything, this is going to increase by probably 4 degrees. And unfortunately, because this was predicted a bit long time ago, now already there are something like 10 years after this, and the actual values are actually tallying with this higher level prediction. So it's increasing actually, even sometimes there's some reports say that the increase is even above this. So we are not addressing it properly. Okay. Then also, this will result in other issues. One of the biggest problem probably is the sea level rise. Why? Melting of glaciers. That is one part, and also with the increase in temperature, water will expand. Okay? Minor contribution, but that's also significant considering the volume. But anyway, mainly because of this melting of glaciers, we will have this sea level rise. So how severe is this melting? Okay, as you can see, compared to 1980, okay, in here like Greenland, so you can see actually now this all is gone. Already all these glaciers have been melted. Okay. Now, if you look at actually the projections, okay, now as it is, probably by the end of this century, there will be something like, now actually it's here, not close to this one. We are going to be here most of the time. There is something like 1 meter sea level rise can happen at the end of the century because of this melting. Okay? But if that entire Greenland ice is to be melted, that will result in 7 meters of sea level rise. How high we are? Ground level from sea, maybe 1 or 2 meters. So you can imagine how much land is going to be under sea if this happens. Can it happen? If you don't do anything, this will happen in 300 years time. Okay? because now even the melting rate is huge. Now it is increasing also. Now this is the Iceland, Greenland ice. Okay. So here earlier the melting rate, the average between 92 to 2001, okay, is something like 34 gigatons. But now the average between 2002 to 2016 is something like 208. So that is something like 7 to 8 times faster than this one. Okay? And it is not stopping. If you have seen videos, you know how fast this is made. So that means if you don't do that, anything regarding the global warming, that 7 meter sea level rise is also possible. Okay. Then also this affects weather pattern, because the temperature is one parameter that decides the weather pattern. So if the temperature is going to change, that will result in changing weather pattern also. Now, this is basically the change in weather pattern between 1900 to 2000. Okay. So compared to 1900, what it is. So this green means it's an increase. Okay. And then this amber means it's a decrease. And the size is like this size means it's 50% decrease, and this one 50% decrease. You can see in some areas actually it's a huge decrease. Unfortunately, most of the time the affected part is the poor countries. And the increase is in mainly Australia, Europe, and the USA. But that increase so is not a blessing also, you know what has happened even maybe a few weeks ago, the damage done by the flooding in the US and also in Pakistan. So that means either drought or too much rain can have significant impact on the environment and the society. So this is ever increasing now, the extreme weather event. So this is very rare, but this is now frequent. In the US, you have this hurricane region. So this is actually in 2017. There were 3 category 3 or 4 hurricanes captured in the one satellite image. And this destruction was something like, altogether, something like 300 billion US. This kind of complete destruction happened because of these changes in the climatic pattern. Then also there are certain things that we should worry more. There are certain irreversible changes that can happen. One of the concern is this thermohaline circulation. Thermohaline circulation is actually responsible for maintaining the temperature pattern in the world, especially seawater temperature, and also it affects the weather pattern. Okay? The thermohaline means there are 2 things, because this is a natural current which is based on the density, the convection. Convection, you know, it density based. So the seawater density will depend on 2 things. One, the salt content. Second one, temperature. Now both are changing. Temperature we discussed. What happens to salt content? Salt content, especially in this region, what happens? That will decrease because of the melting of this glacier. So that affects the density and the circulation. So if this circulation is affected, then there will be a complete change in weather pattern in the world. Even probably our monsoon. Okay? Because all these things are actually related. One key factor is this one. Now, actually scientists predicted some time ago that this is important because this takes this warm water even beyond the UK. And because of that, actually UK, this region has a relatively higher temperature that would have been much colder without this circulation. Okay? So now scientists predicted that this can be affected actually they start to monitor and they already found that actually this is not going as smooth as it has already affected. So now even though we are talking about global warming, there are predictions, some of these regions will be actually subject to ice age, complete freezing because of the lowering of temperature without this circulation. Okay. So this is one concern. And another concern is actually this what I call permafrost. Now permafrost is basically methane frozen. A lot of methane is frozen because of the vegetation. Again, you generate this methane, and in colder regions like the Siberia, huge quantities of these are frozen. Okay. Now with the increase in temperature, now this can be released into the atmosphere. So if the methane in Siberia alone is released because of the warming, that will be something like 70 billion tons. Now how much of carbon dioxide? You have to multiply by the global warming potential. Okay? So something like altogether complete effect will be something like 1.7 trillion CO. Okay? So this is actually much more than what we have emitted during the entire 200 years after the Industrial Revolution. So if this happens, this is not going to stop. Everything will be fast forward, and then you will have melting of ice, complete change in climate pattern, and this is why actually this is a very dangerous situation, even though probably we ignore it. Okay. So this is why actually we have to tackle this problem of global warming. Should we worry about, or maybe something will happen? Someone finds some solution and we can live on. So this is actually the approach most of the time. And also we think, okay, first we will develop and then discuss about those environmental issues. Now, how much you have to worry actually is presented in this article. This is I think like 2006, and it's a very nice article. Still you can access. So it talked about all those what are called tipping point, non-return point. Okay. Beyond that, it will be a completely different system. So we have to definitely be worried. And the other argument I mentioned, okay, let's develop first and talk about the environment later. You cannot do it because now this is actually, and this is done by the Global Economic Forum. So every year they do it. 2021, I couldn't find it. 2021. So they are basically they analyze the risk to global business. Okay. So risk, as you know, there are two components. One is likelihood and the impact. If they can incident, how likely that will happen is one part of the risk. The other one is what will be the impact. Okay. Now that means high risk means higher likelihood and higher impact. Okay. So here we have the highest risk to the global business. Now the things we have here, the highest one is the climate action failure. Okay. So if you fail, climate action failure means we have planned certain action. If you don't implement and if you fail that one, that will bring the highest impact. So this actually came after COVID. And earlier, before that, this was not there. But over environmental regulator, this is not there. Okay. So this is also biodiversity and then also human environmental damage. Then extreme weather. So now you cannot say forget about the environment and do business. You cannot do it. You have to first safeguard the environment and then think of the business. So now the contributors for this problem, okay, so this is mainly energy in different sectors, But I hope you are mostly building sector. So if you take building sector, actually something like energy used in building is 17.5. Okay. In addition to that, actually building material production will also have some contribution. So altogether, more than 20% of the global GHG emissions comes from the construction related activities. So that is one of the biggest contributors. So that means addressing the greenhouse gas emissions from the construction industry is very important. In addition to also other industries, because other industries also consume a lot of energy. Industry 24% and transport 16%. So where do we consume this energy and contribute to global warming? Now, we don't have a good analysis, but this is UK figures. You can see now actually if you take the total GHG emission in the UK, almost half of it comes from the running of building. Energy used for both heating and cooling there, mainly heating. Okay? And then also another 10% comes from the production of building material. So something like 60% is actually coming from building related activity. We don't have figures, but in India this is lower because they don't use much energy. Something like 22% is actually coming from the energy usage. Then also, now when you think of this building construction and their environmental impact, we mainly focus on still the operational stage of the building construction. You try to do everything, reduce the noise, reduce the dust emission and so on. But when you take GHG emission, actually during this one, because of use of machineries and all, something like only 1%. This is again UK value. Something like 1% of the total GHG emission from the building lifetime will be emitted during that. So even if you completely avoid that emission, it's nothing. But something like 82% is actually coming from the building use. Why is that? From where this GHG emission happen when you use the building? Now we are using the building. Any GHG emission? Yeah. Energy. Okay? Because even though we don't generate, if you are using, you are responsible. Okay? So that means this is a major area to be addressed. And this will be a topic today also, because now in the afternoon, Engineer Dalgoda will discuss what you can do to reduce the energy consumption from air conditioner, because main consideration is the air conditioner use of energy, and then also manufacturing of these materials. Okay? So these are also to a certain extent, not certain extent, I mean to a greater extent, have been addressed by the Green Building Council, these codes also, these building codes, because indirectly these are included so that you need to reduce the energy, use better materials, and so on. Okay. So now what to do? So this is our problem. So we have to change. Okay. So if you go as it is, business as usual scenario, okay, you are going to end up here, finishing this huge quantity of GHG in maybe 7 years time, okay, by 2030. So you have to bring in to actually this level to stabilize this one at 450. It's almost impossible now, because now already it's 420, another 30, and you prevent within these 7 years, probably not. Okay? So certain things actually you have to bring down through the technology. Okay? Technological things like this carbon capture and storage in power generation. So you use your fuel, coal, but try to capture CO2 and prevent it going into the environment. Okay? CMA in the industry. CCS is carbon capture and storage. And then go for renewable energy. But your contribution is here. End use efficiency improvement. Okay? So as we saw, building consumes something like 40% of the total energy in the world. So that means a bigger contribution can be coming from the energy saving in building. So to do this one, we need to have certain idea. It's only energy is only one part, but how much is your total contribution to GHG emission? As a person, as an organization, as a country. Okay? So this is where this carbon footprint comes. So what is carbon footprint then? That is the total GHG emissions by a person or by an industry. Now our focus is by an organization, institutional or organizational level carbon footprint calculation. So that is basically how much GHG emission happens from your organization during a year. Okay, so that will be the carbon footprint. So why do you need to know that one? What's the purpose? Not only the total, but also you should know what are the contributing factors, how much is coming from energy and other things. Because that will help you to identify improvement also. Okay? So it's not only the calculation, but also identifying the improvement is also possible through the calculation. So this is what basically we are going to focus today. But our focus will be organizational level. Okay? You can also have this one for projects. It's not covered here, but also like through project you can reduce the GHG emission, and then that is another part. But we are focusing here on the organization level. Okay? So how do you do this calculation and use it? So basically, we need to identify what are the sources. Okay? And then the sources are divided into different scopes, scope 1, 2, and 3. Okay? According to this method given in the GHG protocol, Mr. Pierce is here, he is going to explain how it is done. Okay? And then define your period, last year. And then, so the scopes are based on how much control you have. So we know the sources, like let's say how much electricity you use and how much diesel, petrol or vehicle used. Okay? So that will give you the activity rates. Electricity consumption, total kilowatt hours per year, it's one activity rate. So if you know the emission factor, how many kilograms of carbon dioxide equivalent GHG emission happen when you consume 1 kilowatt hour, that emission factor, okay, multiplied by this, you can estimate this. But to be used this assessment meaningfully, you have to follow certain standards and accepted methodology. Now for organization level calculations, you have to use the standard ISO 14061. Then you have 2, that is on project. Okay, and then because there are two things. One, okay, if it is for internal use, maybe this may not be necessary, but to get a good accurate estimation, you need to probably follow this. But if you are going to declare that your GHG emission or your carbon footprint is this much, then it has to be done according to a accepted standard method. And now it is also required that your statement is verified by an independent third party. So you come up with your GHG emission statement, this much of GHG emission happened, and then that should be verified by an independent party that they will also use another standard to verify whether your GHG estimation is acceptable. Okay? And then you can publish it. But this probably don't need, if your intention is internal use of this one, to identify these areas for improvement and then address them. Okay, so that can also be one part of it, and that is okay. I mean, that is much better than probably just publishing a value and then forget about it. Okay. Then also we have to follow certain principles when you, because this should be accurate and acceptable, transparent thing. Saying that okay, this is our GHG or the carbon footprint. Okay. So there are 5 principles. I am not going to go into detail. The relevance. Okay. All the relevant sources should be included and completely cover things. And then use a consistent method, because now you also want to see the trend. What was our GHG emission or carbon footprint last year, and what are the actions taken now? What is it now? So if you don't use the consistent method, you cannot probably compare. And you have to make it accurate as possible, and the method should be transparent so that the verification is possible for your by your third party. So for this calculation, we use 3 scopes. The direct emission from organization because of the direct use of fuel and so on. Okay, that is scope 1. Then also we have scope 2, mainly the electricity or energy that you purchase and use, and then other activities are included in the scope 2. So mandatory to calculate scope 1 and scope 2 GHG emission. That will be the subject in the next lecture. Okay. So by doing this, basically, we want to achieve as a globe the carbon neutrality by 2050. Okay. So that is the target, but actually sooner the better, because we saw the problem and we are already late, and if you postpone it further, it's not going to help. So at least as organization, if you can go carbon neutral, that will be very helpful. And how to go carbon neutral will also be covered in the today's one of the lectures. And also a kind of case study will be present. Okay. So this is what basically we are going to do during this workshop. So thank you very much. So I hope it will take more time than I've taken. So this is basically a very brief introduction. The important thing is, please understand why we are doing this and take it as a responsibility, not as a kind of privilege that you know this one and use it for personal gain. It should help the organization and also ultimately the country. Okay? Right. Thank you very much. So if you have any questions or anything, we can properly discuss. Any questions, any clarification? Okay, if not, probably we can stop because it's late already.
Thank you very much, sir, for your informative session. Ladies and gentlemen, now you can enjoy with your tea break. Before the tea break, we invite you all to join us for a group photo. So I kindly request you to go ground floor to take the photograph, and please come back after 15 minutes. Thank you. And another announcement for you. The ANAF CBI 4814 white Toyota vehicle, please report us.